Welcome back to our AP Chemistry Chapter 11 notes over acids and bases in equilibrium. I call it Ka, Kb, and buffers because those are really our major topics in the chapter. But one of the subtopics, and an important one that we need to talk about, is salts and hydrolysis. When a salt dissolves in water, it is possible the salt will react with water in such a way as to make the solution either acidic or basic. And this works both if you're just throwing some salt in water and stirring it up to dissolve it. And this works if you're doing a neutralization reaction, because under the Arrhenius definition of acids and bases, an acid and base would produce a salt and water. And so that salt itself could also be reacting with water to make the solution acidic or basic. Okay, so bear with me as I go through like some official definitions and some groundwork, and then trust me, it's going to be a lot easier. I'm going to show you how to work this out actually, and it's a lot easier than it really does sound. Okay, so again, salts will ionize and it could cause a reaction with water to change the pH. And by definition, Bronsted-Lowry definition with conjugate acid bases, acids will give us strong acids, will give us weak conjugate bases, and strong bases will give us weak conjugate acids. And weak acids, as we probably are working with in Ka, will give us strong conjugate bases, and weak bases will give us strong conjugate acids. So you need to watch out for the products when you're doing a neutralization reaction, as well as you're just dissolving some ions. Now check this out. Whichever way I made it, I have some sodium chloride and I'm going to have it dissolve, and so we know it's going to ionize into sodium and chlorine. Sodium could react with water to form sodium hydroxide. Now sodium hydroxide is a strong base, meaning it's going to be a weak acid, so that reaction is not going to occur. Chloride ion could react with water to make hydrochloric acid, which is a strong acid, meaning it's going to be a weak base, and therefore, again, it's not going to react. But what if we start with sodium acetate? The sodium ion would react with water to make sodium hydroxide. Oh, also a strong base, weak acid, so it's not going to react. The acetate ion, however, would form this, acetic acid, which is a weak acid. So it will react with water. So acetate ion will react with water to form this weak acid, and check out what it forms in the process. It's forming hydroxide ion. So what are we going to expect for the type of solution now if we're forming hydroxide ion? Well, hopefully we'd say it's going to be basic, right? So what will be the pH? Please tell me greater than 7. Why then would I use for this reaction Kb? Because we're forming a base. Okay. So what about this one? We have, I'm going to switch to TL. We have ammonium chloride, and ammonium chloride ionizes in ammonium and chlorine. The ammonium would make ammonium hydroxide, which is weak. So yes, that reaction will occur. And notice what it's making in the process. It's making some hydrogen ion. Chloride would react with water to make hydrochloric acid, and that's a strong acid, so that would not occur. So now we have a solution where we're making hydronium, there's one N, one M, hydronium ions. And the hydronium ion would obviously then make it an acid. And so our pH is going to be less than 7. And we would use a Ka to express that reaction. Okay. Now, it might also be helpful to know for things that we're going to be working with that we have this equation to convert from. Check out what it'd help us convert from, Ka to Kb. Ka times Kb gives us Kw, and we know the number for Kw. And by the way, this formula is on your formula chart, so don't memorize it. It's there. Just look it up and use it. But that's exactly how we use it. If I know the Ka, I take our Kw number and divide by Ka, and I get Kb. If I know Kb and I want Ka, I would take that number and divide by Kb. So it's really easy to switch from a Ka to a Kb. So even if I'm like, hey, I only know Ka for this reaction, but I need Kb, well, I can calculate that and no problem. Okay. So what happens if we mix the two, like so far we mixed the two and neither of them have done anything, or the acidic one has done something, or the basic one has done something? What if we mix them and they both will do something? Does that mean it's acidic or basic? Well, the short answer is we don't know then until we compare Ks. And this is where it might be helpful to be able to convert from Ka to Kb. Okay. If we compare Ks and the Ks are exactly equal, then we would get a neutral solution. If Ka is greater than Kb, go figure, it's acidic. If Kb is greater than Ka, then it's basic. Okay. Now it's still, I'm not expecting like acidic as in pH of 1. I'm expecting a weak acid. And I'm not expecting a Kb here of that to give you a pH of like 12. Sorry, I am expecting like a 12 or 13. I'm not expecting, no, I'm saying this backwards. One more time, I'm not expecting a 12 or 13, a strong base. I'd be expecting a weak base like a 9 or 10, something like that. Okay, so that's the groundwork, and we're going to go through some examples, and this is now where it's all going to totally come clear. Okay, so trust me, whenever you're in this situation, just work it this way. Even though it might take a little more time than just doing things in your head, work it this way, and it makes it so much easier. Okay, and everything I said is great, and you probably want to go back and reread it when we're done with these examples, because then it will suddenly make sense what we're doing. It makes sense to me, but I know what we're about to do. So be sure that you do take a moment to do that. I'm dissolving NaCl. What's my possibilities? Well, my possibility is Na positive and Cl minus. So I'm going to give those two separate lines because I literally am hypothesizing. How would you say that? This is my hypothesis. Okay. I don't know how you'd pronounce it in a verb tense, but oh well. So sodium might react with water, and if it does, it's going to give me sodium hydroxide and hydrogen ion. And then I write out chloride might react with water. And remember, water is HOH. Okay, so positive replaces the positive part, negative replaces the negative part, might give me hydrochloric acid and hydroxide ion. Okay, now I take each of these cases individually. Let's look at the first equation alone. I know sodium hydroxide is a strong base. What would a strong base by definition do when placed in water? Please tell me ionize. So am I going to actually form this compound of NaOH? No, it is not going to form. So it's no reaction. That whole line I'm just crossing out. That's not a possibility anymore. Now I look at the other one and I ask the same question. Here's what I could be forming. Will I actually form the molecule HCl? Will that form? Well, HCl is a strong acid, and by definition, what do strong acids do? Ionize completely. This is like the opposite. Is it going to do the opposite? By definition, no. It's not going to form. That compound will not come together. It will not associate together. So if it won't associate either, because it's a strong acid, then no reaction. So now I've crossed them both out. Well, if I've crossed both of my possibilities out, what is it? It's neutral. Okay, it's not an acid because I've crossed out the reaction that could give me an acid. It's not a base because I've crossed out the reaction that could give me a base. It is neutral. And I crossed them out because we're not going to be able to form these compounds because by definition they ionize, they split. This arrow would not be a left to right arrow. It would be a one-way arrow to the left. That reaction will not occur. I hope I've said that enough times. Okay, let's try a new example. Now I have ammonium chloride. And if you're like, hey, didn't we do these above? Yes, I know we did these above, but this is the way to do the same things we did above, but see how to really work it out and get what I said above. So what are our possibilities? Well, from ammonium chloride, I could have ammonium and I could have chloride. And both might, I'm pretending, they might react with water. If ammonium reacts with water, which again is HOH, I will get ammonium hydroxide and hydrogen ion. If chloride reacts with water, which is again is HOH, I could get hydrochloric acid and hydroxide ion. Now I take them one at a time and I look at this compound. Is that a strong or weak base? Please tell me weak base. If it's a weak base, what by definition do weak bases not do? They do not ionize, meaning it will associate. It will come together well. So yes, we will get a reaction. That first reaction probably will occur. Now let's check out the second reaction. Okay, in the second reaction, I make hydrochloric acid, strong acid. We've had this before. What did we say about a strong acid? It will not come together. It will stay broken apart into its ions. So that second reaction will not occur. No reaction will occur there. So of the ones that will occur, what am I making? Oh, look at that. That must mean that my end result is acidic. If I stirred some ammonium chloride into some water, I would end up making the solution a little acidic with that sodium chloride. If I had ammonium hydroxide and hydrochloric acid and I dissolved it in or mixed them together, my solution would not end up neutral when I have equal amounts of each. It would still end up acidic because I have this side reaction going on. Okay, let's try another one. Sodium acetate. Now again, pretend you have your possibilities reacting with water. So I've got my sodium, I've got my acetate. I'm pretending they're going to react with water, and that is to make sodium hydroxide and acetic acid. And now I check each of my products individually. What do I know about sodium hydroxide? I hope you're yelling at the computer that it's a strong base, because it is. Okay, if it's a strong base, will that reaction occur in the first place? No, the arrow would be a one-way arrow away from sodium hydroxide, because that's kind of our definition. Just reminding you, that's really our definition of a strong acid or strong base, is a one-way arrow away from turning it into ions. So no reaction is going to occur. I'm going to cross out that first reaction. What about the second one? Well, this makes acetic acid, which is what vinegar is made out of. And so I really hope it's not a strong acid, and by our definitions, no, it is not a strong acid, it is a weak acid. So this one will occur, this one will form, and as it forms, it will produce hydroxide ion. Right? Okay? So dropping this salt in water will produce hydroxide ions, meaning it will be a basic solution when I'm done. Is this starting to make sense? If not, you might need to rewind a little bit and try those first ones over again, because now it's your turn. Give this one a try. So I want you to pause, and if you don't know what you're doing, rewind the video a little bit and try it again and see if you can figure out what you're doing. So do pause. Yeah, pause it right now. Pause and try and work it out. Pause it. You know I'm talking to you. Pause it. Okay, you should have paused it. If you haven't paused it, stop cheating yourself of this learning opportunity and pause it and try it out. What are possibilities? We could have ammonium ion and acetate ion reacting with water. So let's pretend they do that. And there's my two possible reactions. Now I check one each individually. Would this form? Well, that is a weak base, so yes, it will form. That will associate. Will this form? Yes, that will form. Okay, so I've said yes to both. Oh, if I say yes to both, that means I'm making both H plus and OH minus. Does that mean I'm neutral? I hope you got to this point and said, I don't know what to do next, because that's exactly the right answer. You don't know. If all you have to work with is the salt formula, you would not know if this is neutral or not. To know which one's going to win, is H plus going to win or OH minus going to win? Who's going to break the tie? To know who's going to break the tie, we have to consult Ka values. So I would actually look up this Kb and that Ka. What do I find? I find my Kb and my Ka are identical. It doesn't happen often, but coincidentally it did happen here. So if they're identical, it is in fact neutral. I will get just as much of this as I'll get just as much of that. Now what if I look them up and they're not identical? Well, the one with the larger Ka, that is again closer to 1, that is the smaller negative exponent. I guess there should be a parenthesis there. smaller negative exponent is going to be the winner. It's the one that would make more. So if KB is smaller, it's going to be basic. If if KB is larger, that is a smaller negative exponent, it's going to be basic. If KA is going to be the smaller negative exponent because it's larger, then KA wins and it's acidic. It should be that easy if you have the KAs to compare. If we don't have the KAs, the best you can say on the AP test is we need more information. You, in this particular case, don't know. Now, I have never seen them ask a question about that and have you conclude we need more information. What I normally would see them ask is a question, if it'll go back, come on. Question like the ones we did earlier, come on. Like this, where one is obviously going to be crossed out and the other is obviously not, and then you've got your answer immediately. Okay, so what do you do? What are the steps to figure out if a salt, whether you form it from a neutralization or you just drop it into your beaker of water, what's the process of knowing if it's going to leave the solution acidic, basic, or neutral? You want to ionize it into its cation and anion, and you want to write out the two possible reactions with water. Then you analyze the base and the acid that's made, and if it's strong, you cross off that reaction. If it's weak, you leave it there. And hopefully you cross off one of the two or both of them, and then you know if you cross off both, it's neutral. If you cross off one, it's the other. If you cross off the other, it's the one. If you cross off neither of them, to get an answer, you need to compare KAs to KBs. And if you're not given that information, like on a test, you would have to conclude simply, I need more information to know. And I doubt that's going to ever be the case on the AP exam. So do be aware, I'm expecting like one, if not both, to cross off on the AP exam. But it is truly possible they might give you the KAs. And by the way, if I'm doing this kind of problem and I see both a KA and a KB, I'm probably going to have that as a hint that I might need to compare those to answer my question. Okay, so good luck on your practice of predicting whether salt's going to make a solution acidic, basic, or neutral. It really is not difficult. And as you can tell, it probably made a whole lot more sense when you write out the possibilities and check them one at a time and then see what it's being made than going through all those notes at the beginning. But again, I wanted to give you that foundation at the beginning, really tell you where we are going in words so that now you would truly understand what's going on. And the best thing you could do now is rewind to the very beginning and re-listen and watch those first couple slides to understand now what I'm trying to tell you. But it really is as easy as this. You ionize, pretend your cation and anion will react, and then analyze if those reactants will form. If they will, or if they won't, hopefully it's a combination that tells you whether you'll make some H plus or H minus, and then you'll have your answer. It should be as easy as that. So good luck on your practice.